Good afternoon, everyone, and welcome to the latest in our Global Mapper webinar series. We're so pleased you've joined us this afternoon from cold and soon-to-be snowy Maine. If you hear some chattering in the background, it's probably our teeth chattering here. It's kind of chilly, early onset of winter. My name is David McKittrick. I am Senior Application Specialist here at Blue Marble Geographics. With me today is Cassandra Quintal, one of our esteemed application specialists.
Hello, David. Hello, everyone, and thank you for joining us this afternoon.
Yeah, today we are going to be, as you all are well aware, I'm sure, we're going to be looking at LiDAR data, specifically LiDAR processing within Global Mapper 15, to give it a version. Certainly those of you who have attended webinars in the past, our webinars, will know that we have dealt with LiDAR before. We've talked about importing and processing LiDAR, but it's all by way of leading into another function, perhaps terrain analysis or contour generation. Today, we're going to focus specifically on Global Mapper's work with LiDAR. And there's a good reason for that, because we have just introduced a new LiDAR module, and Cassandra a little bit later in our presentation is going to introduce you to the LiDAR module. Before we get started today, there are a couple of housekeeping issues that we need to cover.
Yes, all attendees are in listen-only mode. However, if you'd like to ask a question, you can use the questions tool on the GoToWebinar panel on the right of your screen. Blue Marble Product Specialists will try to answer your questions as they are submitted, and we'll also address any outstanding questions at the end of the presentation.
Yeah, we have a couple of folks in the sidelines who are waiting for those questions to come in. I know there'll be a lot today. We've got a strong attendance at today's webinar. Also, for those of you who do not have a chance to ask a question today, or perhaps your question does not get answered because of the volume of questions that we sometimes get, or indeed if you're watching the recording of this webinar, obviously we can't interact with you real time via the recording. In any of those cases, you can email us at any time. We have a pretty fast turnaround to questions that come in via email. You'll see that email address right here at the bottom of this slide. It will also be, we'll also give you that email at the conclusion of today's presentation. Couple of events coming up, Cassie, that we're going to be going to in the next, within the next couple of months, I guess.
Yeah, absolutely. The upcoming events that we'd like to point out: on January 12th, we'll be at the Pennsylvania Society of Land Surveyors Conference in Hershey, Pennsylvania. And later in the month, on January 24th, we'll be at the Wisconsin Society of Land Surveyors Institute in Wisconsin, Dells, Wisconsin. If you're planning on attending either one of these events, we encourage you to stop by the booth.
That's right, and also you'll note on here we have a training class coming up towards the end of January, January 21st. It's a one-day training class for those of you who are in the San Francisco Bay Area. We are trying to conduct a training class in that area. More information on both upcoming events that we'll be attending and training is available on our website, and you'll note the links at the bottom of my screen. You can also navigate through our website and find those links. So. Let's take a look at what we're going to be discussing, or what we're going to be covering today by way of kind of a semi-formal agenda. And I should say, although these bulleted points will essentially cover the content of our webinar, they're not in any particular order. As you will see, we'll go through many of these workflows and jump around different functions that pertain to LiDAR processing. Obviously, we want to introduce those of you who have not seen the new LiDAR module. We want to introduce you to that enhanced component that's available for all users of Global Mapper 15. So we're going to talk about the LiDAR module and the functionality that will provide. We're going to start with the basics. We're going to start about importing LiDAR. We're going to assume that there are those of you out there who have not worked with LiDAR in the context of Global Mapper. So certainly we'll go through some of the basic processes, some of the options you have during the import process. Once that point cloud has been imported, we've got a lot of options to adjust the appearance. The visual characteristics of the point cloud can be altered to reflect various components of the data, or to change just the way it appears, maybe change how it appears when you zoom in or zoom out. So we'll talk about some of those options that we have. We're going to talk about editing or reclassifying LiDAR point clouds, as well as simply viewing data or as well as importing a point cloud and using that as a mechanism to create perhaps a terrain surface model. We have a number of editing tools that are available within the software that let you change some of the inherent characteristics of that data. So we'll go through some of these editing functions. This is a new function that we've added fairly recently, the ability to add colors to points from an underlying image layer. Some of you may have worked with point cloud data and been able to visualize, for instance, an elevation value or perhaps an intensity value, both of which we'll cover in a few minutes. But you can also essentially model your point cloud or visualize your point cloud with the actual RGB value, so it looks like a realistic three-dimensional model of the features that are being represented. And we'll show you how in Global Mapper you can actually do that. You can perform that, add that RGB values or those colors to your point cloud data. We have a new tool for automatically classifying ground points. A lot of you who work with LiDAR data will be aware that there are points that go unclassified. These are the dregs, if you like. These are the points that nobody knows what to do with. We've developed a tool within Global Mapper that will allow you to analyze those unclassified points and determine how many of those are actually ground points. Makes them much more useful and saves them having to be discarded during your analysis process. Filtering the data, essentially taking out data that you do not need. There are multiple ways of doing that. As Cassandra will show you in a few minutes, we can filter that data during the import process. I'm also going to show you a little bit later how we can perform certain filters after your data has been imported based on your requirements, based on your needs, and based on the structure of the file that you're using. We will obviously spend some time in our 3D window. Those of you who have not worked with Global Mapper a lot, we do have a 3D component. We have a three-dimensional visualization tool that lets you view data with its Z value or its Z value, and we can work with our point cloud in that context as well. We have a new function that allows you to create a cross-sectional view within a point cloud. Now, it's excellent for visualization. Again, you're looking at a cutaway view of the Z values within a point cloud, but we can also perform edits within that environment as well, within that look, and we'll look at that one a little bit later. Obviously, for most people who work with LiDAR data, there is an end to the process, and very often that is the process of generating a terrain surface. So as far as we're going to go today, we're not going to conduct any additional analysis. We're not going to perform the usual watershed analysis, line of sight analysis that we would with our 3D data, but we'll show you how you get to that point, how you can generate that surface model. And finally, and not perhaps the least important, sorry for the double negative, but the ability to export LiDAR data as well. If you consider Global Mapper and the tools that we're going to show you a viable tool for manipulating, editing, changing the data, well, obviously once those changes are applied, you may want to export that data. And certainly, as you will see, you can export data in LAS, the .las, the standard LiDAR format, as well as .laz. So those formats are supported, both import and export. Now, before we begin, and Cassie, we're going to hand over to Cassandra in just a few minutes, and she's going to talk through the import process. For those of you who maybe have not worked a lot with LiDAR data, and by the way, we are going to be conducting a poll about halfway through our session, and we're going to ask you that question: how many of you work with LiDAR data, or what is your application with LiDAR data? For those of you who maybe have not worked with LiDAR data, brief overview of what the format is. It's essentially a vector point data set, typically airborne, collected data, and that's not always the case. Time permitting later, we'll show you some examples of LiDAR data that was actually collected on a terrestrial collection platform. But typically, on most applications, would be airborne. Laser-based collection system whereby a given point is transmitted towards the ground. It reflects off a given surface, and the reflected pulse is picked up by a receiver on the aircraft. That point then is assigned the characteristics that have been assigned to the hardware during the collection process. Those would include the specific elevation, obviously the specific location, as well as things like the classification. What is that point? Is it a ground point? Is it a vegetation point? Is it a road? And depending on how your hardware is calibrated or how it's set up or configured, you can detect variations on the structure of the surface from which that point has been reflected. So that's the basic structure of LiDAR data. That's what it is. Uses of LiDAR, well, obviously for terrain surface modeling, as we've mentioned. We know a lot of people are using LiDAR data for vegetation analysis. We know a lot of people in the mining industry use LiDAR for creating structures from piles of material and being able to analyze those piles for volume, things like that. So virtually any industry that works in a spatial data environment would have a use for LiDAR data. About 10 years ago, LiDAR would have been considered a luxury commodity for those of us who work with spatial data. Today it's becoming much more readily available. A lot of websites are able to provide data. I would suggest if you're interested in finding data, do a search for your geographic area and see what's available at maybe the government level or educational level. There may be some files available. LiDAR files, I mentioned the collection of data attributed to a specific point. Well, obviously one point isn't that valuable. LiDAR files tend to have multiple points, many thousands, millions, tens of millions, and even hundreds of millions of points. So we're dealing with very large files. The examples we're going to be using today, you'll see, are relatively small, just to allow us to perform the functions that we want to show you, but it's not uncommon for LiDAR files to be over 1 billion points, and Global Mapper will work with those large files. You can certainly crop them down, filter them as needed, but we have developed it to support those large files. So that's a basic introduction to LiDAR. Well, obviously, Global Mapper works with LiDAR. I'm going to switch my screen here and introduce you, those of you who have not seen Global Mapper before, to the application. This is Global Mapper. In fact, this is with the Energy module activated. You'll see it says Global Energy Mapper. Much the same functionality as in the standard version. At least from the LiDAR point of view, we're going to be covering identical functionality. As you will see as we go through the presentation today, there are multiple components of the software that have been adapted to work specifically with LiDAR, and hopefully over the course of the next 50 minutes or so we will introduce you to what those are. Today, for our presentation, we're going to be working with one of my favorite data sets. I've downloaded LiDAR files from many parts of the world. One that I really like to use a lot because it's very striking visually is an area of the coast of Brazil. And Cassandra, I believe you have that file sitting in your back pocket. You're going to show us how to import that data.
Yes, yep. I'm actually going to get started by loading up an image file of where we're going to be working with the LiDAR. I'm going to pull in this dunes data set here, and we'll let it load up on screen. Loading in LiDAR data is the same way as loading in any other piece of data into Global Mapper. You can load it in simply through the File Open option or any other method you might see to be able to pull this data in. And we're going to open up some dunes LiDAR data. We'll open this up here. And as David had mentioned, Global Mapper does support .las and .laz files. This is a .laz, which is a compressed version of the LAS file. Global Mapper also does support the E57 LiDAR formats as well. So I'm going to click OK. And this is going to bring open the LiDAR load options dialog box. On the right-hand side of the box, you'll see the classifications. Classification codes are determined by the American Society of Photogrammetry, and Remote Sensing, or the ASPRS, and they're universally recognized. So right here at the load phase, you can choose to load in all or some of the classifications. Down below that are the return values. Multiple return values usually indicate an above-ground obstruction such as a tree, and this is good for vegetation analysis. So again, you can filter your data right here on import. On the left-hand side of the box, there are the options for loading in the point cloud itself. And by choosing this option, you have the draw mode options as well. So you can bring in the data and visualize it or color it by the intensity or classification or any one of these options right here at loading. The option below that, create elevation grid for use in analysis. When selecting that, it's going to activate the options below it for the gridding options. And this can be done after the data is imported, and I'll be showing that a little bit later. But you have your gridding your grid methods for tinning or binning. You can select your bin size and the distance criteria. The distance criteria controls how far from a known point the grid cells have to be before it is considered invalid. Tight values or values nearing 0 on this side will generate voids or gaps in the data where there's big spaces between each point. If you slide the bar over to the loose side or values nearing 100, this will fill in the gaps with an average flattened value. Below that, you have the option to load points within a specific bounds. This restricts the geographic area that you'll be loading in. And by clicking the select button, you'll see your options for restricting that geographic area. You can either do for what's on screen, you can restrict it by lat long, or by a selected polygon feature if you have one selected on screen. But for today, we'll load in the entire data set. Next is the preview mode. This basically thins the point cloud itself. It enables a faster import of the point cloud. So if you're only looking to preview to see what you have, you can thin that point cloud. Delete samples over a set standard deviation from mean. This helps eliminate any of the erroneous values you might have in the LiDAR dataset. Sometimes I've seen LiDAR point clouds come in with an elevation value of -99999, and you know that's not real. So you can help and restrict that or delete those samples right here on import. The treat elevation as depth. It basically multiplies the values by -1, and this gives you the inverse. So this is great for looking at things that might be subsurface or under the ocean or modeling the ocean floor. And then you can restrict by the point source or the ID that was collected when it was actually collected on the terrain surface. And finally, the last option, you can apply all of these options to a group of files that you might be importing all at the same time. So we'll leave it as is, and actually we'll load in the entire point cloud and click OK. And after it gets loaded in, I think David's going to talk to us about visualizing this point cloud and what Global Mapper offers for visualization.
That's right, and it is worth mentioning at this stage, thank you Cassie, it is worth mentioning that to this point we've talked about the basic, what we consider very basic LiDAR functionality, simply importing, performing certain filters during the import process. This is all available in the standard version of the software. So it's important to mention we're not removing LiDAR support from the standard version of Global Mapper. Those of you who have been using older versions, you'll still get those basic tools. We have added the module to enhance the functionality. You'll see that in a few minutes, what we're going to be adding by way of offering the module. But to this point, anybody with any version of Global Mapper could have performed what Cassandra just did. So visualization, well, obviously right out of the bat, we have the point cloud rendered as what appears to be an elevation model. It looks almost like a solid surface. Quick look at the Overlay Control Center in Global Mapper tells me that this particular file has just over 7 million features. In this case, we know they're points. These are LiDAR points. Now, we're only seeing a small area. I'm not zooming to the entire extent. It's not much larger than we have on screen, but this would be considered a fairly small LiDAR data set. So as you can see, just over 7 million. It looks almost solid. If we zoom in a little closer here, you'll start to see the individual points. And here we're right down to the level where the imagery that appears behind is actually getting pixelated. And if you note my scale at the bottom of the screen, a meter indicated by my cursor right here, we're looking at sub-meter resolution for this data. These points are within a meter of each other. Obviously 7 million points distributed throughout this area gives you a very valuable data set. And you'll see the colors, and the colors will be reflected in the elevation legend over here on the left-hand side of the screen. Those of you, again, who have used Global Mapper will be familiar with this component, more typically used when you actually have a terrain surface, and you can see that, as I said, on the left side of the screen. As far as the visualization of the point cloud is concerned, before I go any further, I want to show the ooh and ah feature, the 3D modeling capability. Because each of these points has a Z value, or has a Z value for those of you who live in certain parts of the world, it can be inherently modeled as a 3D model. And right up here in my toolbar, I have a 3D button. It's going to pop open a new window. And just very quickly, we can go and see our 3D model. You can start to see, in this case we mentioned that these are dunes. You can see the dune array right here very clearly. You can see some buildings, and obviously these buildings are in some danger with these encroaching dunes. That's why this data has been collected to analyze this movement. But here we can see the point cloud as a 3D model. We'll get back to look at the 3D window a little bit later in a different context. A couple of the other visual edits that can be applied. And I mentioned, by the way, when I was introducing Global Mapper's work with LiDAR, that there are some unique capabilities that we've added to the software. One of those is the options. I'm speaking to those of you who have probably used Global Mapper for a while, perhaps imported shapefiles or worked with your own vector data. When you click the options button, it will give you a very specific set of options pertaining to how those points or those features appear, labeling, etc., etc., etc. With LiDAR data, it's a completely new set of options. Under LiDAR display, we can choose how to visualize this data. I'm going to show you a couple of examples of how to change the characteristics of visual characteristics to reflect different components of this data, and essentially to expose different characteristics that tell a slightly different story. One example here is if I change the color by intensity. I'm just going to leave the window open and click the apply button. Quite difficult to see in its current form, but basically this reflects the intensity of the returned point from that laser transmitter. If I adjust the brightness slider at the bottom of this window, hopefully it will become a little bit clearer. Okay, I've washed out a little bit of the colors, but the patterns you see are now a little bit clearer. A lot of people look at this visualization and say, hey, it looks like an aerial image. It looks like a black and white aerial photograph. And it does, because the point intensity is a direct reflection of the feature that it's hit. So you can see here a visualization of intensity. We can also visualize based on classification. If I enable that option, again I'll click apply, it will show me the colors that have been assigned to the different classes of data. Now you'll note at the bottom right corner a legend has automatically appeared indicating that my brown points are ground points. Those are the ones that most people will be most interested in, but certainly it's not all that's in this data set. We have we have actually high, low and medium vegetation, various shades of green, and then we have our model key point, our mass point as well included in here. I can tell already that there's some problems with this data set. We know vegetation are shades of green, but we can see quite clearly that we have buildings here. Now, whoever collected this really didn't care much about buildings, so they just basically had ground and then everything else was assigned as either a vegetation point. I'm going to show you a little bit later how we can change that, how we can, through a process, change these buildings, what we know are buildings, to be actual buildings within the LiDAR point cloud. Some of the other visualization options we have here, we can visualize by return number, by source point ID. The source point ID will show us basically the breakdown of the flight lines. Very clearly we can see green, red and blue indicating the source ID numbers that were assigned to the points collected during that collection process. So we're not changing the data, we're simply changing how it's presented. You will notice the first option here says colors if present. Well, there are no colors in this case, so it defaults to elevation. Elevation is kind of the backup, if you like. So natively, this particular file does not have colors assigned. As I will show you a little bit later, once we have activated the module, we can actually assign the colors to each point. Currently, we don't have them there, but we'll get back to that one a little bit later. Also within this dialog box, there are options for adjusting the point size. I would suggest in most cases leaving it automatic, but if you want to have each point at a specific size, you can manually override the defaults and specify exactly what that size is. You can also apply a thinning process, and obviously the benefit of a thinning process is going to be faster display. Thin the points down, they're going to draw faster, or you can slide it the other way for a higher quality data set. Those are the two options that we have available in here. You can, by the way, change the colors that are assigned to the classifications. I didn't mention that before. I'll get to that a little bit later. Again, something we can get to when the module has been activated. Those brown ground points, if we want those to appear a different color, we have full control over that. There's obviously a default set of colors that are applied, but we can change those as needed. One more thing I want to show you before we hand back to Cassie, and I will be coming back and continuing this process of dissecting and working with this data. We have the ability to visualize the density of the points. Now, I'm going to conduct this process for just what's on my screen. We know this particular point cloud has a much larger geographic area, but in the interest of time, I'm going to restrict it to what's on my screen. Now, those of you who are frequent webinar attendees may have seen me use this particular tool in a different context, perhaps for a different application. But what I want to do right now is I'm going to create what's called a density map or a density grid. Many people may refer to this as a heat map. Again, to reflect what we're seeing on the screen right now, those increased intensities of colors are indicating where the higher areas are. We know the dunes are here. Looks like there's a higher area down towards the bottom of my screen. I'm going to change. I actually want to create a new layer using the same color patterns, but it's going to have a completely different application. And again, by right-clicking in the Overlay Control Center, I'm going to go to creating a density grid. Now, I'm going to first make sure that I don't spend too much time on this. I'm going to limit this to just what we have on screen. This, again, is the same dialog box that Cassandra showed you a few minutes ago in a different context, allowing me to constrain the geographic area of this particular process. I'm also going to limit the size. I'm going to change my dimensions to be our square meters. So hopefully everything else here is fine. If you haven't seen this tool, by the way, and you want more details, I recommend going back to some of our previous webinars, and you'll find more information on things like creating a density map. Quite simply now I'm going to click OK. And this will take just a few seconds to create my density grid. And when it does, in my Overlay Control Center, you will see a new layer. That new layer will actually be a raster elevation layer of sorts. In this case, the Z value does not actually represent a height or an elevation above sea level, but rather it represents a reflection on the concentration of the data. Now, the easiest way for me to visualize this is actually to turn off all other layers. Again, to clarify, what we're seeing on the screen right now is an analysis of the concentration of returns from this LiDAR point cloud. And one of the striking things you'll see are these apparent seams. If you remember back to when I adjusted the appearance based on the point ID, well, these reflect the flight patterns. And where there's a little bit of an overlap, you can see there's an increased concentration of points. As there are in areas of vegetation, I know there's trees along this area, so you can see heavy concentrations in certain areas. This is another analysis tool that's available within Global Mapper. And again, this is a standard version. This is the standard version of Global Mapper we're using for this analysis. So. I am going to close that overlay, and one of the things we always recommend everyone who uses Global Mapper, if you're working on a project and you want to make sure anything you've done is saved, go ahead and save your workspace. And I'm going to practice what I preach. I'm going to do that right now. I'm going to save the workspace. Because what we're going to do now is we're going to hand back over to Cassie. And Cassie, I believe you are going to tell us about the module and how to activate the module.
Yes, absolutely.
Before we start, I'm sorry, Cassandra, I apologize. We are seeing some questions coming in. There's one question I think is very pertinent and very relevant, and it's a good segue to what you're going to be covering. Someone's asking, the LiDAR module, will it work with version 14 of Global Mapper? I'm going to throw that one over to you, Cassie, by way of introducing the module.
Absolutely, and that's a great question. The LiDAR module was actually introduced with the release of Global Mapper version 15. So the LiDAR module will work with version 15, but not with version 14. To activate the module, you'd have to go into the Help menu. And right down here towards the bottom, you'll see Module and Extension License Manager. So if you select that, you'll get the Module Manager box. And as you can see, the GEM module is already activated, and you know that by Global Energy Mapper there at the top of the screen. We'll be activating the LiDAR module. So if I click that box, it's going to present me with the registration screen. For this, I'm going to load in a a license file that was provided via email, and I select that option and click Register. And I'm going to navigate to where the license file is saved. If you're interested in getting a license file and gaining access to the LiDAR module, feel free to contact our sales department and we can provide you with that information at the end of the presentation. So we'll click on the LiDAR and my license file is right down there, and I'm going to click Open. We do also offer a 2-week free trial to the LiDAR module, and you can access this through this module manager as well. So as you can see, it's selected now, and we can click OK. And up at the top of your screen on this bar, it does indicate that the LiDAR module has been activated. So you can see right here to know that you do have the module activated. Great. I think next we'll probably want to find out who's using LiDAR and what you are using it for.
That's right, Cassandra. We actually have a poll, as I mentioned before. Sorry, I'm interrupting you. We're going to launch our poll. Just to let you know what's going to happen here, you will see on your screen, hopefully in the next few seconds, a question. The question actually this month is actually a multiple answer question. In other words, you do not have to choose one of the below. You can actually choose as many as you want. So this is kind of uncharted territory for us as well. The question we're going to ask is, how do you currently use LiDAR data? And rather than me reading the options, I'm going to go ahead and launch the poll, and hopefully you'll see the questions. Check as many of the boxes that are relevant to you, and we'll gauge the results as they come in. Straight off the bat, a lot of people are using it for terrain surface and analysis. That's not surprising. Quite a few of you are actually not using LiDAR data. We're looking maybe at about 1 in 5. That number's going down now. It's interesting to see the results coming in. We're going to leave this open for just a few more seconds, so go ahead and click. We'll give you a little bit longer than we do normally because there's multiple options to choose from, but eventually when we're done, we'll go ahead and show you the results of this so you can see who else attends our webinars. So we will go ahead and close the poll. Okay, so interesting results. 84% of you are currently using the LiDAR data for terrain surface generation and analysis. Interestingly, if you add that to the 14% you're currently not using, there's almost 100% right there. So you're either using LiDAR for terrain surface generation or you're not at all. So some of you are distributing LiDAR data. Obviously, we've got a few that are collecting. That's about a third of you are involved in the collection process. Hopefully, you'll see that Global Mapper is a good additional tool in the collection process for initial visualization and the analysis that we're going to show you as well. And then some of you, about half of you are involved in processing and editing the point cloud data. So interesting results. Thank you for participating in our poll. Moving along, I have a small subset of the file that Cassandra was looking at previously. By the way, just to kind of confirm, the action of activating the LiDAR module enables the LiDAR toolbar, as you'll see. I'm just going to pull it down so we can see it a little more clearly here. We have a number of new functions in here, a number of buttons in here, a number of shortcuts. Certainly a much more convenient way to work with and interact with your LiDAR point cloud data. And we're going to be going through the functions that this provides throughout the rest of our presentation today. Someone asked a question. I'm just looking down through the question. Someone's asking the question. Obviously, they've been doing a little homework. Went to our website and could not find the LiDAR module. Where do you download the LiDAR module, they asked. Well, you don't. The LiDAR module is actually included with the installation of the software. So when you download Global Mapper, the latest version of Global Mapper, version 15, the LiDAR module is actually in there. The activation process, that should have looked familiar to those of you who have registered Global Mapper in the past. That dialog box for registration will appear and allow you to activate or unlock that function. So there's no additional download that's necessary for that process. So the next section assigned to me is the process of filtering or editing the data. And again, there's a number of tools that we have at our disposal for performing that type of work. Very simply, if I use my feature info tool in the toolbar and select a random point. You'll see the standard feature information dialog box within Global Mapper shows us all of the information that's been assigned. Our elevation is obviously an important one. The classification we've talked about, this particular point happens to be a ground point. Intensity value, return count, GPS time, and our source ID. So each point within this point cloud is going to have this information associated with it. So we can look at an individual point level. We can also edit at an individual point level. Now, the likelihood of you actually doing this is pretty remote in truth, but you can. Again, this time using the digitizer tool, I've selected a point. I'm just going to right-click and use the standard edit function. And you'll see when I do that, I now have a unique set of editing capabilities pertaining to that point. Again, we're seeing the information. This is a ground point, its elevation, its intensity. Now, it's not likely you're going to come in here and change the elevation or, for that matter, the intensity. That's not usually done. You can change the classification on a case-by-case basis. Now, again, I show you this as a first step into editing. The likelihood of you going point to point for all 1 million plus points in this subset of our data, quite unlikely. But you do have that capability. Now, the thing is, you can also perform the same editing with multiple selected points. And again, all I did with my digitizer was select a large group. Once again, using my edit function, this time it's seeing multiple LiDAR types selected. If I want to make these all a particular classification, I can do that universally. Again, I can make them all a specific elevation or intensity value as needed. So individual editing, multiple selection available simply by interacting with those points right on the map. We can also apply an editing process through our normal search dialog box within the application. We have a search tool. Now, this search tool actually performs what I would consider to be two key functions. I'm going to minimize this window or bring it down just a little so we can fit it on screen. This allows us obviously to search for particular elements of our data, but it also allows us to essentially visualize and sort and organize and manipulate the data in its tabular form. Again, what we're looking at here is a tabular view of the 1 million plus points. And you'll notice my little spinning circle here. What I've asked it to do is to sort these points based on elevation. It'll take just a few seconds to perform this, and when my spinning circle goes away, as it just did, we can now see the range of elevations within the entire point cloud. And you'll see as I scroll down, hopefully the broadcast version is showing this increase in value. At its very basic level, I can use this window to select those points that I'm most interested in. I can delete them. I can universally edit them. Any of these attributes can be edited. So at the tabular level, I can get right into the point cloud and do some modification, some manipulation, some editing as needed. Again, using simply a sort tool as I did here. Dialog box also lets me specify what it is I'm searching for. Again, as an example, and I'm not going to actually conduct this again in the interest of time, but if I wanted to find all of those points that are over a specific elevation, I can choose elevation, I can choose greater than, less than, whichever is appropriate, and then simply type in the value and it will filter my results right here, allowing me to manipulate those, allowing me to assign those to a new layer, whatever it is that I need to do. We can conduct multiple levels of search. So if I only want the ground points that are over a certain level, I first conduct a search on the class, contains the word ground, and then a search in existing results for my elevation thresholds. So this window, although it's not primarily intended for LiDAR processing or LiDAR manipulation, has a significant role to play in that procedure. Just be aware if you're dealing with large volumes of points, you may have to wait a little bit of time to process, but it will do that work for you very, very efficiently. So one filtering method, manual selection, another filtering method through the search dialog box and the results of that first dialog box. Looking at my toolbar, there's an option right here. That's the penultimate button, I guess, the button one from the end on the right side. I can filter the data based on its classification or based on its return number. So same dialog box that Cassandra showed us during the import process can now be applied after the data has been imported. You can filter by return type or filter by the classification. Easiest way to filter a specific classification is to disable all and then check what it is that you want to see. And I'm just going to enable my ground points in this case. I'll click OK. And you'll notice my data has been filtered. You can see definite holes where there are buildings and intense vegetation areas. I've only got my ground points displayed now. Another way of filtering data, another way of creating essentially a subset, or allowing you to create a subset of your data, is through one of the options that is available for a point cloud. We went to the options dialog previously to adjust the visual characteristics, to change how the points appear, to decide on which variable within our point cloud to adjust those visual characteristics. We can also go to the alter elevation values. This is not a new function as well. This is a function that was available for any elevation data, but it certainly has applicability when it comes to working with point cloud data, because the valid elevation range values, while they currently reflect the full extent of what's in this area, I can change these. If I only want my point cloud data that's above, let's say, 30 meters, I can type that value in there, and it will again filter my data at a very specific cutoff point. The points that would be rendered on the map would just be those that are above 30 meters in this case. Again, I'm not going to perform that, but that's another option we have for filtering the data. While we're looking at the toolbar, let's take a look at some of the other buttons that have been added. Well, obviously we currently have the drop-down as well, where the drop-down will now allow us to choose the same variables that we looked at when we were in the options for that layer. Now we can do that right from the toolbar. Again, varying the visualization based on any of these options. We have a number of shortcut buttons that allow us to reclassify. If I select a point, I can simply click the particular icon, low vegetation, medium vegetation, high vegetation, buildings, ground points. Those are the common ones. So for instance, if you have unclassified points, you can very quickly, just simply by toggling this button, or by clicking this button, I should say, change those to be ground points. We have a tool for automatically detecting ground points. Now, in order to perform this, I'm going to go back and unfilter my data. I'm going to turn on everything once again, because I know in this case we have some unclassified points. And to verify that, by the way, we can look at the metadata for a selected point cloud right again in my overlay control center. With the LiDAR point cloud layer selected, I'll choose metadata, and there's standard metadata variables in here. The coordinate parameters are noted in here, the volume of the data that's in this layer, but we also have a more detailed statistical breakdown. This is again unique to working with LiDAR data, where we can see a breakdown of the point distribution within this layer, both in terms of its classification, its return type. If it's the first return, typically a single return would be a harder surface. A second return would imply perhaps some vegetation. So you can see the return variables listed here. So again, you can see the breakdown in terms of the point count, point percent, as well as the Z-min and max for each of these criteria. The one that I'm most interested in here is these unclassified points. There are not that many in this layer. You may find a particular point cloud that you work with has a lot of unclassified points. What we're going to do is we're going to analyze those classified points to determine which of those are likely to be ground points. And there's an automated tool right in the toolbar for doing that. Simply by clicking on this button, specifying which layer, or for that matter, which layers to apply this to, we can perform a calculation essentially based on a deviation from a defined area, and specifying the bounds if necessary, which of the points that are currently unclassified are ground points. And in this small data set, it went pretty quickly. Now, we didn't actually see the results in this case, but we were able to essentially take those redundant points, those unusable points, and make them part of our ground level model now, simply by performing that calculation to determine if they're within the proximity of a ground point that's within an area. And that's an automated process, another tool that's available for us right in here. The final button in the toolbar, one of my personal favorites, is the ability, as I mentioned previously, to assign an RGB value to the point cloud data. You will notice that my selection in the drop-down indicates that these point cloud points will be colored by RGB by default, or elevation if that's not available. That's why we're seeing our elevation colors right now. By simply clicking on this button, and it happens pretty quickly, well, many of you might assume that the point cloud disappeared. We're no longer seeing it, but that's because the point cloud has actually inherited the colors from the imagery that I've just turned off. You will see very clearly the buildings. Let me zoom in a little closer. I'll use my zoom tool. And you'll see the points thinning just a little bit. Again, this looks like an image, but it is actually a point cloud now with the RGB values assigned to each point from that underlying image. Now, I'm not sure if Cassandra's going to be showing you this a little bit later, but I'm going to jump the gun a little bit because I love to view this in 3D. If you look at the point cloud now as a 3D model, you can generate a very, very interesting fly-through. You can almost see the buildings and the vegetation layers right in here. Based on that point cloud. So very interesting perspective, now more visually realistic than simply representing one of the variables at the point cloud collection level. Now this actually reflects what's on the ground at that particular point. So that's an option that's available with the LiDAR module. And I believe that oh, sorry, I'm looking at my notes. Apologies. A couple of other things as far as editing is concerned. These are, again, you're not unique to working with LiDAR, but worth mentioning in this context. I'm just looking at my bullet points here. Reprojecting. Obviously, the LiDAR point cloud that you import will have an inherent projection. Global Mapper needs to know where it belongs on the surface of the Earth. If you have a need for reprojection, it's a simple process of going to the configuration dialog box and changing those projection parameters. This is a UTM projected file, zone 22. If you need to reproject to a different system, that's an option that's available right here in the configuration dialog box. Deleting points, some of the basic editing functions, being able to delete points. Again, the digitizer enables that functionality. In this case, I'm simply right-clicking. I'm going to right-click and delete. We have the option to delete points. So points can be manually deleted. We can crop the data as well. I'm going to draw a very arbitrary shape right here, obviously not with a lot of care and attention. This shape may represent the defines of an administrative boundary. Because what we can do with this shape created, or this shape imported, let me select it first. So you can't quite see it because it's underneath the point cloud, but that shape has been selected. We can go and we can crop that. We can right-click and we'll have the option to crop all of our loaded features to that area. So again, this is another editing tool. I'm not going to go through with it, but basically what that would do would be remove all of those points that are outside of our area, leave those that are in the area. That's a standard option for any vector file. Certainly can be applied for our point cloud data. And one more thing, Cassie, sorry, one more thing that's again available, because this is again a standard vector layer, we have our shift option. So if you need to manually manipulate the specific location of your point cloud, this allows you to shift the layer in a defined direction. So my apologies, Cassandra, I'm jumping ahead here. So
oh, no problem at all. A couple of questions have come in. After you've done all of these edits, how do you then export or save what you've edited in the point cloud?
That's a question we get a lot. Those of you who have been through our training classes will know that's a question that's asked during training. Almost every training class I get asked that question, regardless of the format of the data. So in this case, we've imported a point cloud, a raw LiDAR data. We've performed some manipulation. Let's say we've done some edits, added our RGB values. It is important to note that any edits we make within the software are not automatically applied to our source file, and that goes with any file that you import into Global Mapper. The source file is still intact. If I need to apply the changes that I've made to this point cloud into a LiDAR file, into a LAS or a LAS file, that would require an export process, which is a good segue. Finishing the kind of the workflow where you bring your data in, manipulate it, change the appearance, delete erroneous points, apply filters as necessary. You can then certainly turn around and export those points again. So for instance, if I go back into the dialog box where I was just looking at my ground points. Let's disable on, turn on my ground points, click OK. We can now go through a standard export process, choose a vector format data set. This is a vector file, and you will notice right here both LAS and LAS are supported as export formats. So if your workflow is simply bringing in a point cloud, doing a little data QA, data scrubbing, cleaning it up, filtering, and getting it out into a usable LAS format again, Global Mapper will serve that function very, very well.
Awesome. Another great question that just came in is, where can I find LiDAR data?
Oh, that question, where do I get it? This particular file, just to give you an example, I searched, I was actually we were preparing for a webinar for some folks in our South American customers, and I wanted to find some local data. So quite simply, I searched for LiDAR Brazil, and I was directed to this particular project site. That's obviously a very casual way of doing that. A good starting point for those in the U.S. is the USGS Earth Explorer. They have archives of data that can be downloaded. State level, here in the state of Maine, we have a certain amount of data that's available for download. I often cite the state of Minnesota as being one of the better states within the U.S. For providing data. You can download data for the entire state directly from their GIS archives. Outside of the U.S., I'm sure there are government agencies that will provide this. It very often requires perhaps delivering a hard drive because of the volume that's required, because of the size of the files. So Google searches is the best right now. Certainly LiDAR data is more available than it used to be, but it still may take some searching. The availability will improve as time goes on, though.
Awesome. Thank you, David.
Yep.
Moving on, I think I'll move into creating an actual terrain surface. So about 84% of our viewers did say that they generate and analyze terrain surfaces using LiDAR data. So I'm going to move right into showing that. I think David's loading up a new point cloud for me that's ready to go. Oh, this is the imagery, and there is the LiDAR. First, let's filter so we are only looking at the ground points, which I believe is what we're looking at right now, but I'll double check. So, yep, our ground points are selected. Click OK. And to start generating or creating this terrain surface, you'll find the option in the Analysis menu. It's the top option, Create Elevation Grid from 3D Vector Data. So this generating a terrain surface can be done with not only LiDAR points, but any vector data that has the z-value or a three-dimensional value. So selecting that option, you're presented with the options dialog box. The description right there at the top, you can name the layer, and that's what's going to show over in the Overlay Control Center. We'll just leave it as is. You can select the vertical units for your terrain surface, either meters or feet. Next is the grid method. Global Mapper provides the user with the ability to triangulate or tin the points, as well as binning for min, max, and average. So binning is when you cluster the points into a bucket, and we can designate the size of that bucket, if you will. We'll do an average value bin. The spacing for points, we're going to set that as 3, so that's basically the size of the bin. And again, I went over a little bit earlier about the distance criteria, and we'll leave it over on the far right for no data or the loosest of values. It's going to average all of the spaces where the buildings are void of the terrain surface. And then there's a couple of options down at the bottom. The tiling tab allows you to generate smaller files. So if you're working with a really large data set and you want to cut it up into smaller tiles, you can do that with this tab, and it provides you with the ability to designate how the tiles are going to be generated and the naming convention for those tiles. And then the grid bounds is the same as restricting the geographic area. So we're going to just run the terrain analysis for the data that we have loaded on screen. And we're going to click OK. So it's going to bin all the points and find the average value for all of the points within that bin. And all right, so now we have created our terrain surface. I'm actually going to turn off the LiDAR so we can take a look at it on screen here. This red section is the sand dune that is encroaching on the residential neighborhoods around it. And let's move the imagery up so that it will be on the surface of the terrain model. And I'm actually going to turn on the LiDAR points, and I'm going to filter so that we see all of the points that are not classified as ground points. There we go. And I'm going to enable all and unselect ground and click apply. And you'll see those populate up on the screen. Now I'm going to actually throw this into our 3D viewer and take a look at the terrain surface that we just generated here. It might take a few seconds to load. I do have quite a bit of data represented on screen here. If I zoom in, with the point cloud actually visualized it, you can't really see the definition of the terrain surface I just generated. So maybe I'll go back in and turn off the terrain surface so that we can see the detail that's available when you actually generate the surfaces from the LiDAR points. It's moving a bit slow on my side. David, would you be able to maybe...
Sure, I'll take over and drive here. We're trying to perform this in kind of a remote situation. But I think, just to clarify here, what sure. Cassie had done is basically taking out the ground points. They have served their function, essentially, generate the terrain surface model. Perhaps moving the imagery to a point where you actually see the imagery, and then going into 3D. And obviously, we didn't record the colors that assigned. We actually removed that feature, but if we'd done that, we could have visualized those color features as well. So again, in 3D, what we're getting here is the surface model, and you can kind of look under the buildings, etc. So it gives you that option. Certainly in an urban area, this is much more useful, where you can see the buildings extruding very cleanly from the surface model. But we're visualizing a point cloud as well as the generated surface model and the imagery layer as well. So.
Thank you, David.
Yeah, a couple of things I'm noticing our time, Cassandra, apologies, and there's two things I really do want to make sure I cover here. I'm actually going to keep your data up. I'm going to turn the imagery off, and I'm going to turn your elevation grid off as well. We've got our point cloud. I'm actually going to remove the filter. We're going to go ahead and enable all. I had alluded to this function earlier, and glancing down at my notes, I realized I didn't actually get to it, so I apologize, but I want to make sure that you're aware that this is another function that's available with the LiDAR module, which is extremely useful. I am going to change the visualization of this data to be by classification. And let's try that one more time. I'm not quite sure why it's not taking here. Things are a little slow in responding. Hopefully eventually it will. Let me remove my elevation grid. I'm going to close your elevation grid. We'll proceed anyway with this analysis. I'm not quite sure why my classification visualization is not being applied, but we have the profiling tool in Global Mapper. This again is not a new function. Those of you who have used Global Mapper for a while with elevation data will be aware of this tool. But we've enhanced this function, enhanced the use of LiDAR to allow profiling of a LiDAR point cloud. I'm simply going to draw a very simple little line, and you will see when I do that. Let me change to classification. There we go. That works a little bit better. So we're visualizing this point cloud now based on its classification. Now, what we were looking at in 2D in our top-down view was obviously the ground points with what were defined as vegetation. Now, I drew this line, this profile line, across what I knew was a building. I know for a fact that it's not a vegetation layer. These points within this area are a building. This is the roof of a building. By the way, the profile view can be expanded as needed. Under path setup, you can specify the corridor width. I believe it's 5 meters in my case, so it's encompassing the entire roof of this structure. But we also have editing capability right here in this profile view. I can collectively grab all of the points that I know are not vegetation points. I'm not so sure about these. They may be some plants or something, but certainly this is the roof of a building, and I can automatically, using the buttons I described previously, automatically reclassify these as a building. Now you will see immediately that they will change color, both in the 2D environment, and if we go back to our 3D view, unfortunately again it's not changing my view by classification at this stage, but if it were, you would see that color by classification view right here. Now,
yeah.
Sorry, go ahead, Cassandra.
Upon import, you can select, specify the colorization pattern at import. So maybe upon importation, it didn't select the classification.
That's fine. And one final thing, again, we are almost out of time, but the one final thing I do want to show you. 2 or 3 months ago, maybe a little bit longer, 3 or 4 months ago, I talked about scripting in my webinar, and we got a lot of very favorable response to that webinar. For those of you interested in working with LiDAR data, you can also apply a script, and I have actually developed a very simple script, which I'm going to open up a notepad very quickly so we can see what it does. I'm going to import, or essentially point to a LAS file. It's the same LAS file we've been working with today, and from that I'm going to automatically generate a gridded surface. From that I'm going to generate some contours, and I'm going to export that as a shapefile. So those of you who are involved in processing LiDAR based on a standard set of procedures, this is just an example of how that procedure can be automated. If you want more detail on how a script works or how to build a script, again, go back to the scripting webinar from 2 or 3 months ago. You'll see it on our website, and you can see the details of how to create a script. As you can see, it's not overly complicated. Basically, I'm asking it to do certain actions just through simple text commands. Now, the process of generating my script will hopefully generate a file in this folder called contours. It's not there right now, but I'm simply going to double click on my script file to initiate that process, and you'll see, although we're not actually seeing Global Mapper is hard at work. And if I open up this contours folder, you can see it generated some contours for me. So there's an example of how we can take a point cloud data set, perform several processes, simple gridding, generating contours, and then exporting that to a shapefile, in my case, in one fell swoop. And again, it's another way that Global Mapper will allow you to work with LiDAR data. With that, we'll go ahead and wrap up. We overshot our time just a little bit, and I apologize for that. We've reached the end of the year. I was going to say next month, next year, I guess. January. Check your inboxes in the next week or so. We'll hopefully have an announcement of the webinar coming up towards the end of January. Thank you for attending today.
Great, yes, and if you want to sign up early for the January's webinar, details can be found at our website, which David has just pulled up on screen. And hopefully our support crew has answered any questions you guys may have had. If you do have any further questions, feel free to send in an email to geohelp@bluemarblegeo.com, and we'll address it then.
And as I mentioned earlier, thank you, Cassandra. And I mentioned earlier, we are recording this. This will be posted. Give us a few days to get it all processed, but it will be available on our website. And if you want to revisit the webinar, maybe share it with your colleagues, by all means, it will be available for viewing online. So,
great. Thank you, David, and thank you, everyone. We look forward to speaking with you at our next month's webinar.